Hello, students. Welcome to chemistry. Well, I hope you had a great spring break. I had plans to go to Miami. That had to all be canceled. So all I had was an imaginary tropical vacation.
I guess we'll have an imagination Christmas this year.
Yay! Imagination Christmas! I got a pogo stick. I got a hula hoop.
Man, I wish I had an imaginary hula hoop. But, social distancing. Anyway, I've got some great chemistry lessons for you. I'd actually like to do a few labs. So I'd like to ask you to start collecting things so we can do some labs at home. Some of you told me you can't do a lab at home. That's okay. I'm not going to mark off any credit if you can't get the supplies. But if you can, it'll just make things more fun. If not, I'll give you an alternative assignment. But everybody has to do a few labs. And so here's some of the things that you will need. Coffee filter paper. And all you need is one of these. And they're pretty inexpensive. So this is maybe 5 cents worth. And you don't even need a whole one. We're going to cut it into a strip. We just need a little wedge about this big. That's all you need. So find it somewhere and then keep it, put it in your sock drawer, keep it in your wallet someplace where you're not going to lose it. If your home is not a coffee drinking home, and you don't have any coffee filter paper, the next best thing is paper towels. Again, you don't need a whole sheet of paper towels. We're just going to cut a strip maybe 2 inches wide and maybe 6 inches long. This is all you need, so you have at least a week to find this. You can also use a napkin instead of a paper towel. And if you can't find that, any absorbent paper will do. So once again, you have about a week to gather these things. Also for the lab, you'll need just a couple, at least one marker. And it would be best if it was an expo marker, a dry erase marker, or a washable marker. Maybe you have a younger brother or sister who has some washable markers. You just need to borrow it. You're not going to use up the whole thing. But you need something that's washable. So like a Sharpie, a permanent marker, that would not be good for the lab. Something like a dry erase marker, something like a washable marker. Some of these markers have a nice scent for kids. That kind of marker you will need. All right, something else you might need for another lab is a 2-liter bottle of Diet Coke. So if you can get that, that would be terrific. And then I'd like you to get something else. See if you can get mint Mentos. Now Mentos comes in different flavors. The other flavors will not work for this experiment. It has to be mint Mentos. And the last thing you need to get is baking soda and vinegar. This small box right here is all you need. It costs about 90 cents. And you don't even need this much, but vinegar, I bought white vinegar. This will do just nicely. The baking soda and vinegar lab will do in about 2 weeks. So you have even more time to get that if you can. I know there's social distancing going on. I know that the stores are out of a lot of things, so I'm not going to judge you at all if you can't get these items. But it'll just be a more interesting experience, a more educational experience if you can do some of the labs. We will also have some labs where you don't need anything at all because some of you asked for that. So we'll have a completely online lab, at least a couple of those, and that's coming up. But please take your schoolwork seriously. I just want to show you something online here. So here is the last lesson I gave the Friday before spring break. And take a look at this, 42 views. Now I have 90 students. So this number should be at least 90. So I'm very concerned a lot of students are not doing what they're supposed to be doing, and that is watch all of my lectures online and doing all of the work. It is for your benefit. It would be a foolish thing not to do what I ask you to do. So if you haven't seen that video, the first minute or two is just a joke. If you don't like my jokes, just skip ahead. But then there's a whole lesson. I go over a problem that a lot of students got wrong, and I even got a few thank yous for the lesson. People said, I did not understand it until you explained it. So make sure you're watching the past lessons because they are designed to move you forward in chemistry. I wish you a successful week. Feel free to email me if you have any questions at all. And now, let's get started with the opening. Opening. What is the law of conservation of mass? We already learned this. This is a review question. I know it's easy for you to look up the answer on the internet. I'm going to ask you to resist the temptation to do that. Instead, try to recall it from memory. It's very good for your brain when you try to do that. So write down a couple sentences to the best of your recollection. Pause the video at this time, and then I'll tell you the answer. Okay, we're back. What is the law of conservation of mass? Today we're going to review the law of conservation of mass, and then we are going to be introduced to writing chemical equations, something brand new and something that's very exciting, but it's a little bit difficult. You do have to keep up. You have to keep watching these videos. Make sure you don't fall behind. I want you to be very good at writing chemical equations. I think it's something that's fun. It's like solving a puzzle. So if you keep up and you'll learn it, we're going to have some fun with it. It's going to be a fun thing, but you do have to follow what I'm teaching so that you don't fall behind. All right, the law of conservation of mass. Let's do a review of that. The law of conservation of mass states that matter cannot be created or destroyed under normal circumstances. The quantity of mass is conserved. And here's a little bit of a more formal definition. The law of conservation of mass states that for any system closed to all transfers of matter and energy, the mass of the system must remain constant even if it changes in the arrangement of its atoms. So if you did not have the correct answer written down, I would recommend you pause the video and write this definition and study it. Make sure that you know the law of conservation of mass. It is one of the founding pillars of chemistry and one of the more important things that you need to know for chemistry success. All right, so we talked about this in the past too. Just a little review. We have two nails here. One is not very rusty at all, and this nail is very rusty. And just about 100 years ago, people observed that in a way, it seemed like the rusty nail was losing something. It was certainly losing strength. But on the other hand, Antoine Lavoisier showed that the rusty nail actually looked like it was gaining something. It was gaining in weight. It was more massive than the nail that wasn't rusty. So he designed an experiment, and this resembles a lot what that experiment looked like. If you were to take a nail that's not rusty and put it in a sealed container, sealed from all flows of changes of matter and energy, and you have some air in the container and some water in the container, over some time, it might take a few weeks, the nail will start to rust and the nail will get more massive. It'll actually increase in weight. At the same time, there will be less air in the container and less water. And if you were to weigh this whole system, you would see that it never changes in weight because the amount of mass the nail is gaining is the exact amount that gas and liquid is being lost. So that is the law of conservation of mass. Things might change. A nail might get rusty, we might have less water, we might have less air, but the whole system remains the exact same mass. So here's the equation for iron rusting. 4Fe plus 3O2 yields 2Fe2O3. What does that mean? Well, this first number means moles. So 4 moles of iron plus 3 moles of, do you remember what O2 is? It's dioxygen. So 3 moles of dioxygen yield 2 moles of, do you remember what this is? This is iron 3 oxide. And something that's new here is this 4, this 3, and this 2. The 4, 3, and 2 are coefficients. They multiply the things in the chemical equation. So let's talk about that for a minute because that's very important for writing chemical equations. Let's talk about coefficients. So here's O2. This is 2 oxygens bonded together. This is what you and I are breathing right now. And this is what it looks like. 1 oxygen atom double bonded to another oxygen atom. Oxygen has an oxidation number of 2, so it wants to bond to 2 things. This oxygen's bonded to 2 things. This oxygen's bonded to 2 things. There's a double bond. That is O2. What if I were to put a 2 in front of this O2? Right now it implies there's a 1 in front of the O2. Whenever there's no number, it implies a 1. But what if we put a 2 in front of the O2? Can you imagine what that would look like? It would look like this. It's just 2 O2 molecules. And because we have 2 of them, there's actually 4 oxygen atoms. 1, 2, 3, 4. And I can see that visually, but if this picture weren't here, I'd be able to calculate it. I would take the coefficient of 2, and I would multiply it by the subscript. 2 times 2 is 4. And that's how many oxygen atoms we have. 1, 2, 3, 4. What if I put a 3 here? What if the coefficient is 3? Well, that's going to look like this. Now we just have 3 O2 molecules. And 3 times 2 is 6. And let's count them. 1, 2, 3, 4, 5, 6. So if you have a coefficient and you have a subscript, you just multiply them. And that allows you to calculate how many of the atoms that you have. In this case, we have 6 oxygen atoms. And of course, if the coefficient is 4, we have 4 O2s. 4 times 2 is 8. 1, 2, 3, 4, 5, 6, 7, 8. That is how coefficients work. Let's look at a different example, something slightly more complex. Let's look at a water molecule, H2O. 1 oxygen bonded to 2 hydrogen. There's no coefficient here, so that implies the coefficient is a 1. This is 1 H2O molecule, but the coefficient also means 1 mole of H2O. Okay, so you can imagine 6.02 times 10 to the 23rd of these. But right now, let's just imagine that it just represents 1 H2O. What if we put a 2 here? That would be 2 H2Os. It would look like this. And take a look. 2 times 2 is 4. That would indicate we have 4 hydrogen atoms. 1, 2, 3, 4. And 2 times 1, this would be implied as a 1. 2 times 1 is 2. That would mean we have 2 oxygen atoms, and that's what we have, 1, 2. What if this were 3? Well, that would just be 3 water molecules. 3 times 2 is 6. 1, 2, 3, 4, 5, 6. And 3 times 1 is 3. 1, 2, 3. That's what 3H2O means. So let's go back to the chemical equation we were looking at for the rusting of iron. This says we have 4 iron atoms plus 3 dioxygens, which is actually 6 oxygens. That yields 2 iron 3 oxide molecules. Now, what is Fe2O3? It looks like this. 2 irons bonded to 3 oxygens. That's what it looks like. And this coefficient tells us that there's 2 of them. So here's another one right here. When there's a 2 here, it multiplies the entire molecule. So we had Fe2, 2 times 2 is 4. And you can see 1, 2, 3, 4. And 2 times 3 is 6. That would imply 6 oxygen atoms. And let's see if we have 6. 1, 2, 3, 4, 5, 6. So you can see it's pretty easy to calculate. Even if these pictures weren't here, it's pretty easy to calculate how many atoms we're dealing with. These coefficients often refer to just the individual atoms, but often they also indicate moles. So they're used in both ways. So get used to looking at this equation in 2 different ways. Anyway, we're going to be looking a lot at chemical equations this week and next week. And today's our very first day. That was our introduction to chemical equations. The end.